Imagine standing under a quiet winter sky as a mysterious interstellar visitor drifts above you.
That visitor is 3I Atlas, a traveler from far beyond our sun's reach.
At first glance, it looks like any ordinary comet wandering through the cold darkness.
Hubble and Webb captured familiar signs: coma, gas jets, and a slender trailing tail.
But the deeper we looked, the stranger this visitor became.
Its chemical fingerprint revealed unusually high carbon dioxide levels, far beyond typical comets.
Think of opening a freezer expecting ice, but finding dry ice instead.
This imbalance hints at a birthplace wildly different from our solar neighborhood.
Then came the strange polarization signature, the way light twists passing through its dust.
Every comet leaves a pattern, a kind of optical fingerprint shaped by its surface.
Yet 3I Atlas showed a fingerprint unlike any comet we'll ever measured.
It was deeper, narrower, and impossible to reconcile with familiar comet behavior.
Scientists began wondering whether this object was hiding a story we hadn't heard before.
Even estimating its size turned into a puzzle with a frustratingly wide range.
Some readings suggested a small, compact core, others a giant, several kilometers wide.
Imagine trying to measure someone's height through thick fog. That's our challenge here.
These inconsistencies aren't errors. They're signals that something unusual is happening.
In astrophysics, the strangest objects are often the ones that teach us the most.
And 3I Atlas quickly joined that small club of cosmic troublemakers. Its interstellar origin alone makes it precious, a message from a distant system. Think of it as a postcard from another sun, worn by time and cosmic radiation.
The more we studied, the more questions replaced our assumptions.
Why does it stay active so far from the sun when most comets lie dormant?
What drives its shifting tail, changing shape like a restless flame?
And what lies beneath the veil of dust that keeps hiding its true size?
Some wondered if cosmic rays shaped its surface over millions of lonely years. Radiation can reshape molecules, turning simple ices into complex chemistry. If that's true, we are studying a body sculpted by the harshest environment imaginable.
But even this idea leaves key mysteries unanswered.
For example, why hasn't the comet fractured under thermal stress? Comets usually crumble when sunlight hits them too hard.
Yet 3I Atlas remains intact, as if built from something stronger than expected.
This resilience forces us to rethink what interstellar objects are made of.
Meanwhile, amateur astronomers fueled the mystery with surprising images.
Their photos showed a shape much cleaner than professional observatories revealed.
Could different processing methods really change the story this much?
Or is the comet revealing details only certain angles or instruments can see?
Science thrives on questions, and this object delivered them generously. Some people leap to exotic explanations, imagining deliberate engineering. But extraordinary claims require extraordinary evidence, which we haven't found.
No signals, no impossible materials, no physics-defying maneuvers.
Still, the temptation to speculate reminds us how powerful mystery can be.
Curiosity is natural, but the universe preferred honest investigation over fantasy.
And investigation continues as Atlas moves farther from the sun each day. Our opportunity to study it is shrinking, just like its fading light. Every new observation becomes a precious clue in a rapidly closing window.
Just a glimpse, then the fog took him. He planned this.
The best hope is to capture enough data before it slips away forever.
And when it leaves, it may carry secrets we'll never see again. Still, the mysteries it leaves behind will reshape our understanding.
3i Atlas teaches us that not all comets follow rules we thought were universal.
Some wanderers are shaped by environments far stranger than our own. Others carry scars from journeys spanning millions of years across the galaxy.
These travelers broaden our perspective on how planetary systems form.
They remind us our solar system is only one story among countless others. Each interstellar visitor is a rare opportunity to read a chapter.
Three-eye Atlas might not fit neatly into our comet definitions.
But science grows when definitions are challenged by reality. This object pushes us to revise assumptions we once trusted.
And that is what makes its visit so important, even if brief. We may never see another object exactly like it in our lifetimes.
But its mysteries will spark research for decades after it's gone.
It's a network. They're communicating.
This structure, it defies all known physics. We have to report this immediately.
Atlas could be the first clue in a larger cosmic puzzle.
Or it could be a lone outlier, a cosmic oddball with no siblings.
Either way, it forces us to ask better questions about the universe.
Why do some interstellar objects behave like nothing we've seen before?
And what hidden environments created such unusual chemistry? Could cosmic rays alone sculpt a body into something this unique?
Or is there an unknown process we haven't yet uncovered?
These questions are not roadblocks. They're invitations to discover.
Atlas shows us the universe is not obligated to follow our expectations.
Objects like this challenge the quiet confidence we build from familiar data.
They remind us, scientific certainty is always temporary.
And that humility is essential when exploring a universe this vast.
So as 3i Atlas continues outward, we keep watching and learning.
Each faint photon it reflects becomes part of its story. And each new measurement becomes another page in ours. Maybe someday, another interstellar visitor will answer questions Atlas leaves behind.
Until then, this strange traveler reminds us how little we truly know.
Imagine stepping outside on a quiet winter night, with a warm cup of coffee in your hand.
Above you, a faint object glides across the sky with a purpose that feels mysterious. That object is 3i Atlas, an interstellar visitor passing through our cosmic neighborhood.
But tonight, the story isn't told by NASA or Hubble. It begins in a backyard.
A 6-inch dwarf telescope captured an image that startled professional astronomers.
The image showed a shape far too clean and sharp for a normal comet.
Comets usually blur and fuzz like dusty snowballs falling apart.
But this one looked polished, almost intentional, like something designed.
Amateur astronomer Paul Craggs didn't expect to disrupt the field that night.
Yet his backyard image forced scientists to ask an uncomfortable question.
What did we miss? Became the whisper moving through astronomy forums.
It wasn't just the clarity, it was how unnatural the clarity felt.
Professionals compared it to suddenly finding a polished stone in a muddy field.
In science, anything too clean can be just as suspicious as something too messy.
Large observatories process images to remove noise and sharpen data.
But sometimes that process accidentally removes rare details instead.
Meanwhile, backyard observers often stack raw frames manually.
This different workflow can preserve subtle features normally filtered out.
It's a reminder that smaller tools sometimes reveal what bigger ones hide.
3i Atlas exposed a blind spot in how we handle astronomical data. Imagine trying to clean a dusty painting and wiping away important brushstrokes.
That's essentially what high-power processing can do to Comet images.
The backyard approach kept those brushstrokes intact. Craggs' photo sparked debate because it didn't look accidental.
Some saw an engineered shape. Others saw a trick of image stacking.
But nobody could deny the image demanded a second look.
The shock wasn't that an amateur took a good picture.
The shock was that his picture showed something professionals hadn't.
It raised a deeper question, hidden inside the excitement. Are we too dependent on big machines to tell us what's real? Astronomy used to be driven by human patience and clear skies.
Today, automated systems analyze the sky before our eyes even look.
Yet a backyard observer still managed to see something first.
This became a humbling moment for science, a reminder of its roots.
Historically, amateurs have discovered comets, supernovae, even planets.
3I Atlas adds another chapter to that tradition.
Some Caucasian male scientists argued the sharpness might be an optical illusion. Others believed crags captured an angle rarely visible to large telescopes.
Both sides agreed on one thing. The image couldn't be ignored.
You don't disrupt professional astronomy with a blurry picture.
But this wasn't blurry. It was shockingly defined.
It made people wonder if the universe reveals itself differently at smaller scales.
Or if our biggest instruments sometimes overcorrect the truth.
The debate became a global conversation within days.
Suddenly, everyone, from amateurs to researchers, was re-examining their data.
Backyard astronomy had stepped into the spotlight again. And it asked a bold question without speaking a word.
What if our simplest tools still hold the power to surprise us?
Atlas didn't care whether it was photographed by NASA or a hobbyist.
The universe shows the same truth to anyone patient enough to look.
And patience is one thing amateurs have in abundance.
Cragsel's image became a symbol of scientific humility.
It reminded us that discovery isn't always about scale. Sometimes, it's about perspective.
And perspective can come from anyone, anywhere, with the right curiosity.
3I Atlas showed that even small instruments can shift big ideas.
It pushed scientists to question their assumptions more carefully.
It pushed amateurs to aim higher, believing their work truly matters.
And it pushed all of us to look up again with new attention. Because sometimes the universe speaks softly through small lenses. And when it does, the message can shake an entire field.
Atlas may leave soon, but its lesson will stay long after it's gone.
It taught us that discovery is still democratic. It reminded us that anyone can make a difference with enough curiosity.
And it proved that the sky is not reserved for professionals.
The universe belongs to all of us who dare to look up.
Imagine standing on a dusty Martian plain, watching a small, bright object drift across the sky.
That moving point could be 3I Atlas.
Scientists expected a typical comet, but Atlas behaves nothing like the usual kind.
The first strange clue appeared in how its light came back to us,
Light behaves differently depending on the surface it touches, like clues on a fingerprint.
But Atlas returned a polarization pattern deeper and narrower than any comet ever recorded.
Imagine a chef tasting a familiar soup, suddenly hitting a completely unexpected flavor.
That's how astronomers reacted when they saw that unusual light signature. Polarization shouldn't look like this unless something unusual sits on the surface.
Maybe its dust grains are shaped differently, or far smaller than normal.
Or perhaps its outer layers were resculpted by millions of years in interstellar space. Then another mystery appeared. Atlas becomes active far earlier than other comets.
Most comets stay quiet and frozen until sunlight warms them.
But Atlas wakes up early, releasing gas where others remain asleep.
It's like seeing someone run their air conditioner in the middle of winter.
This early outgassing suggests unusual ices or unexpected internal heat.
Scientists can't agree yet which explanation fits best.
And then there's the shape of its tail, constantly shifting, refusing to settle.
Normal comet tails stretch steadily away from the sun.
Atlas sprouts multiple jets firing in different directions.
Even stranger, it forms an anti-tail, pointing toward the sun instead.
Antitails are rare and tricky, appearing only under special conditions.
Atlas seems to produce one effortlessly, as if it's built for odd behavior.
Imagine a garden sprinkler firing in unpredictable directions every few seconds.
That's what Atlas looks like when its jets erupt across its spinning surface.
These patterns hint that its internal structure may be fractured or irregular. Or maybe parts of its crust heat unevenly, venting gas like tiny geysers. Scientists expected a simple comet, but Atlas feels more like a puzzle box.
Every measurement reveals new behavior that breaks old assumptions.
Why does its light twist strangely? Almost like it's being filtered.
And why won't its tail stay still long enough to look normal?
Each answer creates two new questions, like a cosmic riddle. Some models suggest its outer layers might be unusually fragile.
Others argue it may rotate on a wobbling axis, reshaping its outgassing.
Wobbling can create unpredictable jet patterns, like a misaligned firework.
But none of these explanations tie everything together neatly.
The truth is, Atlas may be shaped by environments we've never studied.
Traveling between stars exposes material to extreme radiation and dust.
Interstellar travel can change chemistry in ways we don't fully understand.
Perhaps we are seeing the fingerprints of that long, lonely journey now.
Even
Even its tail may hold clues about where it came from.
Scientists are tracking each twist of its tail like detectives chasing clues.
The deeper they look, the stranger the picture becomes.
Atlas behaves like a comet, yet refuses to fit comet rules.
It's not breaking physics. It's stretching our understanding of it. Unexpected behavior often opens the door to breakthroughs.
Atlas might expand how we define comets in the future.
It challenges the comfort of familiar models astronomers rely on.
But that discomfort is the heart of scientific discovery.
Atlas reminds us the universe rarely behaves by the book. And sometimes, a single object forces us to rethink everything.
Each new observation of Atlas becomes a potential breakthrough.
These mysteries aren't obstacles. They're invitations to explore deeper.
The strange polarization, early activity, and shifting tail all whisper of something new. Atlas may be the most confusing traveler we've seen in years. But confusion is often the first step toward understanding. And this interstellar visitor is teaching us more with every passing day.
Imagine holding a river stone, worn smooth by time and endless motion.
Now imagine that stone drifting through space for 1 billion years. These particles strick constantly, reshaping its chemistry molecule by molecule.
Some scientists think this is what happened to 3I Atlas.
Cosmic rays may have carved its crust into something unusual and unfamiliar.
They might even explain Atlas's strangely high carbon dioxide levels.
Think of it like heat transforming dough into bread. Chemistry changes with energy.
Cosmic rays carry immense energy, capable of forging new compounds. Over millions of years, they could build complex organic molecules. But this theory has a crack that scientists can't ignore. If its surface has been so heavily battered, why is Atlas still intact?
Most comets grow fragile after long exposure to radiation.
Yet Atlas survived perihelion as if nothing happened.
That survival forces us to rethink what cosmic rays really do.
Could radiation actually strengthen certain kinds of icy layers? Or did Atlas develop a protective crust during its long interstellar journey?
Imagine ceramics hardened by intense heat. Maybe something similar happens here.
Or perhaps only the outer skin is altered, while the core stays untouched.
If so, cosmic rays tell only half the story.
Atlas might be tougher than we expected, for reasons we haven't modeled yet.
Sometimes physics isn't missing a mystery, it's missing a detail. Tiny processes we overlook can create massive effects in space.
Maybe our comet models don't reflect interstellar conditions well enough.
Atlas reminds us that not all comets form in familiar solar nurseries.
Its chemistry might be born from environments we have never seen.
Cosmic rays could sculpt that chemistry into something unique.
Still, this doesn't answer why Atlas didn't crumble near the sun.
Some researchers think deeper layers hold the object together.
Others suspect the processed crust behaves like a protective shell.
Maybe radiation turned the surface into a kind of cosmic ceramic.
Or maybe our assumptions about fragile, long-traveling comets are flawed.
When data refuses to fit, science must adapt.
Atlas forces scientists to revisit old beliefs about interstellar objects.
Survival challenges what radiation damage really looks like.
Could the damage be shallow, affecting appearance but not strength?
If so, we're misinterpreting the signals Atlas sends us.
Consider how a tree's bark can be rough while the trunk stays strong.
Atlas might operate on the same principle across cosmic scales.
The surface may be ancient and scarred, but the core resilient.
This hybrid structure could explain both its chemistry and durability.
Still, many questions remain unanswered.
Why does radiation create so much CO2 in this case?
What processes produce the organic molecules seen in its spectrum?
And why does the comet endure stresses that break others apart?
Each question pushes us deeper into uncharted scientific territory.
Atlas may be showing us physics we haven't formalized yet.
It reminds us, the universe doesn't owe us easy answers. Sometimes the explanation is simple. We just haven't recognized it.
Science grows by confronting what doesn't make sense.
Atlas is one of those rare objects that force progress. Even an incomplete hypothesis can point us in the right direction. Cosmic ray processing might be that imperfect guide. It explains much, but leaves room for deeper physics to emerge. And that'll the beauty of science. Knowledge expands through its gaps. Atlas carries those gaps like scars etched by the galaxy itself.
One day we may understand every mark, every molecule, every layer.
Until then, Atlas reminds us to stay curious and keep questioning.
Imagine reviewing telescope photos
and suddenly spotting something that looks strangely structured.
That surprise is exactly what happened with the image of 3I Atlas.
The photo sparked a wave of excitement across astronomy forums.
Some claimed it wasn't an artifact at all, but a real fuselage-like shape.
A shape too sharp to belong to a dusty, chaotic comet.
This clarity led some to consider something extraordinary.
What if Atlas was more than a natural interstellar visitor?
Reports of smooth, non-gravitational acceleration fueled the idea.
Comet jets should cause jittery motion, not smooth propulsion-like shifts. That smoothness made some imagine hidden thrusters at work.
But imagination often runs faster than the data. Nothing in Atlas's behavior actually violates physics.
Still, the allure of an artificial object is hard to resist.
Humans are wired to find patterns, especially ones that feel meaningful.
When people want to see a spacecraft, they often will.
This is confirmation bias, a powerful force in perception.
It fills the gaps when information is incomplete. Atlas provides plenty of gaps for the imagination to play in.
But let's look at what the science actually tells us.
No unusual metals have been detected in its spectrum.
No radio signals or structured transmissions have been found.
No behavior demands technology to explain. Everything observed so far fits natural comet activity.
Even the fuselage-like shape can arise from image-stacking artifacts.
Or from catching a comet during a moment of unusual jet geometry.
But the mystery remains irresistible to many.
Humans love big possibilities, especially when details are fuzzy.
And Atlas arrived with perfect timing to spark that curiosity. It's the kind of object that invites speculation simply by existing. A visitor from another star system always invites big questions. We are naturally tempted to imagine intention rather than chance. But extraordinary claims demand extraordinary evidence.
And Atlas hasn't offered that evidence yet.
Absence of signals matters. Machines usually communicate.
And the absence of exotic materials matters too.
Natural explanations remain far more likely.
But the artificial object theory teaches us something important.
It reveals how quickly imagination fills scientific uncertainty.
It reminds us to separate wonder from assumption.
Wonder inspires questions. Evidence answers them.
And science needs both in healthy balance.
Atlas sits right at that dividing line.
A natural object that feels mysterious enough to spark speculation. The mystery wasn't the light, but the shapes that followed. Whispers from the void,
but grounded enough that science still rules the conversation.
Some see structure, others see illusion.
Both reactions reveal more about human psychology than Atlas itself.
We seek meaning, even where none may exist.
Atlas becomes a mirror, reflecting our expectations. And that may be its most fascinating quality.
Because sometimes the mystery is not in the object, but in our minds.
Atlas invites us to question what we think we see.
It challenges the stories we attach to the unknown.
And it reminds us that science begins where assumptions end.
The artificial object idea won't disappear soon.
But for now, the data stays firmly on the natural side.
Atlas is strange, yes, but not impossible.
And the universe doesn't need spaceships to amaze us.
Sometimes nature itself is more surprising than any imagined technology.
In the end, the mystery keeps us looking deeper.
And that curiosity is the real engine driving discovery.
Imagine standing outside on a cool night, wondering what drifts beyond our solar system.
Somewhere out there, Three-Eye Atlas moves silently through the dark. Its presence reminds us how small our scientific map truly is.
The universe doesn't care about our tidy classifications.
It makes no effort to fit into our boxes or definitions.
Three-Eye Atlas behaves like something beyond our expectations.
Have you ever noticed how we expect the cosmos to follow our rules?
Objects born in other star systems follow different histories.
Atlas is one of those rare travelers shaped by foreign environments. It carries stories from a place we may never see.
And yet, we try to force it into familiar categories.
But the universe has no obligation to match our diagrams.
Consider how strange it is that we assume we've seen everything.
Atlas challenges that assumption with quiet confidence.
It reminds us that cosmic visitors don't follow our curriculum.
They arrive with behaviors that seem out of place.
Many expect comets to behave like members of our solar family.
But Atlas didn't grow up under our sun's influence.
It comes from a place shaped by different chemistry and radiation.
No wonder it plays by different rules.
Have you ever watched a traveler from another culture act unexpectedly?
Atlas is the cosmic version of that moment.
Instead of confusing us, it invites us to rethink old assumptions.
It shows us the limits of our models with gentle precision.
Our solar system's comets formed from one ancient disk.
But Atlas was forged in an environment we can't trace.
It may have endured collisions and extreme radiation.
Its scars belong to a journey we can only imagine.
And still, it remains intact after millions of lonely years.
That durability itself surprises researchers.
It refuses to fit predictable comet behavior.
And that refusal teaches us something vital.
We don't know as much as we think we do.
Atlas exposes the blind spots in our cosmic understanding. It's a reminder that curiosity matters more than certainty. Because certainty can blind us to new discoveries. But curiosity keeps us searching deeper.
Atlas encourages humility in every observation.
Humility helps science grow beyond old boundaries.
Think about how many impossible things became normal over time.
Each began with a moment of uncertainty, like this one.
Sometimes the mystery is the point, not the answer. Atlas reminds us, space is far less predictable than we imagine.
And that unpredictability is what drives exploration.
When an object doesn't fit our charts, we learn something new.
Atlas breaks those lines with graceful defiance.
Your rules work here, not everywhere.
What else might we be wrong about?
Surprises still drift between stars unseen.
Atlas is only the third interstellar visitor we have spotted.
That number alone tells us our sample is tiny. The universe likely contains countless strangers like it.
And each visitor could hold clues to distant worlds.
But clues only help when we're humble enough to listen.
Atlas teaches us our cosmic education is far from complete.
It urges us not to rush to conclusions. Not everything strange demands an exotic explanation.
Sometimes the lesson is simply, keep looking.
Atlas is a visitor that expands our sense of possibility.
And expands our awareness of how little we truly know.
In that sense, humility becomes a scientific tool. Because humility keeps us open to the unexpected. Atlas didn't bring us an answer. It brought perspective. And sometimes, perspective is the most valuable discovery.
Breaking news confirms that another interstellar visitor has just passed our sun. This is the second such object detected this year.
3I Atlas is only one of many to come.
Future observatories will turn these rare sightings into routine discoveries.
The Vera Rubin Observatory will scan the sky every few nights.
It will catch faint, fast-moving objects with incredible sensitivity.
Rubin can detect interstellar bodies within hours of arrival.
No visitor will slip through unnoticed anymore.
The Roman Space Telescope will reveal their chemistry in detail. Roman's wide field view will map structures we've never seen before.
Together, they will transform how we study wandering interstellar travelers.
Imagine discovering dozens of such visitors every decade.
With numbers comes clarity and patterns.
We'll finally know whether Atlas was unusual or typical.
Maybe its strange behavior will turn out to be common. Or maybe Atlas was the cosmic outlier of its generation.
More samples mean more reliable answers.
Science grows stronger when uncertainty shrinks. Each new interstellar object is a message from another star system. These messages carry chemistry shaped by foreign suns.
They also carry scars from cosmic radiation across millions of years. Rubin and Roman will help decode those scars.
And build a library of interstellar fingerprints.
Imagine comparing 20 male travelers from 20 unknown systems.
Some may be carbon-rich, others dust-starved or ice-heavy. Diversity itself could reveal hidden laws of planet formation. What if Atlas represents a whole new class of objects?
A family shaped not by stars, but by interstellar travel.
Long exposure to radiation might unify their traits.
Or each object may be wildly different from the next. Either outcome rewrites our understanding of small bodies.
We may learn that our solar system is just one version of many.
And that other systems produce objects we've never imagined.
Interstellar objects remind us how little we know. But future observatories will fill those empty regions with data.
We're entering a time when cosmic visitors become expected.
Instead of rare surprises, they'll become weekly headlines.
This shift will change planetary science forever. We'll discover which properties come from formation.
And which come from the long, cold journey between stars.
Atlas taught us how strange a single visitor can appear.
But imagine the surprises hiding in the next 100 visitors.
Future telescopes will detect them earlier and clearer.
We'll track their paths from the moment they enter the heliosphere. Some may even be close enough for spacecraft encounters. Direct sampling could reveal chemistry frozen for eons. And unlock clues about distant planetary nurseries.
Them. Interstellar research will become a cornerstone of modern astronomy.
Atlas may be remembered as the catalyst for this revolution.
It sparked questions too big to ignore. Questions that future observatories are built to answer. The more objects we find, the sharper our theories become. Patterns will emerge from the chaos of discovery. And those patterns will reshape our cosmic worldview.
Maybe Atlas was unique, an odd wanderer.
Or maybe it's the first member of a vast interstellar family.
Only future discoveries will decide which story is true.
For now, the sky is preparing to reveal much more. And we're finally building the tools to listen.